are some strategies that we've learned to solve multiplication equations. So we started talking about these strategies yesterday, but what are some strategies that we've learned? What's up? Yeah, that's fine. Because we're going to get interrupted in a second anyway. Miranda? Break apart. This is my favorite strategy because it makes me change, it lets me change a hard multiplication problem into an easy one. Does anyone remember what the actual math name is for break apart? We've been calling it break apart, but what is the math term for it? Brinley?
Distributive property.
Distributive property. Very good. All right, what else is a strategy for multiplication? What else is a strategy? Lucy? Skip counting. And that's going to work super well, especially with my easy ones. My easy ones for me and probably for you are my 2s, 5s, and 10s. Give me a me too signal if your 2s, 5s, and 10s are your easy ones. Those are the ones that are easy for me too. What's another strategy we've learned for multiplication, Brayden?
Addition?
Yeah, we can do that repeated addition. This is probably the slowest strategy, but that does not mean that it is not correct. Just because it takes you a long time does not mean that it's not going to work. Okay? Eliana, what's another strategy?
Array.
We can make an array, and we've been making those in many different ways. We've used counters to make arrays. We've used dots to make arrays. On your math workbooks, you might have used some smiley faces to make arrays. Yesterday, we used rectangles to make arrays. All of those are different versions of an array, but they're all still an array. Yes. Brinley?
The commutative property.
The commutative property can help us, but they're not going to help us solve that. So you're correct in saying it might be easier for your brain to think of 2 times 4 instead of 4 times 2. And so you can make that switch, but that doesn't actually help you get the answer. You see what I'm saying? So it helps us think about multiplication, but maybe not solve it. Ethan? Circles and dots. Yep, that would be a good model. It's very similar to our arrays. Brayden, anything else? Doubles. Doubles are a good one. What are some examples of doubles? We talked a lot about doubles. What are some examples? Miranda?
Double dash.
Yeah, like what? No, that's addition. I don't want addition. 2s and 4s are doubles. Any other doubles? Any other doubles? Other doubles. We have 2s and 4s. Grace?
5s and 10s.
5s and 10s. We might not use doubles very often for 5s and 10s because they are our good skip counting numbers, but they definitely still work. Any other doubles?
Anything like 2, it could be 2, 4, 6, 8.
No, those are not going to be our doubles because 2s don't double to 8. That's a lot of doubling. I just want 1 pair of doubles. Scarlett? 3s and 6s. We did 3s and 6s. Now, you could really use doubles with anything, but for 3rd grade purposes, this is a really good start. So, all those strategies, that's a lot of strategies. We're now at the point where when you see a multiplication equation, I need you to be a little reflective. I need you to think a little bit before you just start answering it. What is going to be the best strategy? Because it's a 5 times 9. Does it make sense to draw an array? Probably not. Because you guys are good at skip counting by 5s. If it is a 12 by 12, does it make sense to do repeated addition? Probably not. That one might be better for break apart. That's pretty tricky. So you're at the point now where when you get a multiplication equation, you're going to have to choose which strategy makes the most sense. Because sometimes doubles will work. Sometimes break apart. Sometimes good old-fashioned skip counting. You get to make that decision now. You're going to hear me say a lot in the next couple of weeks. Do what makes your brain happy. I can tell you what I like, sit up, but you have to make that choice. You decide what makes your brain happy. Because I will tell you, I'm not a doubles. Doubles don't work so well in my brain, but I know they do for certain people. Alright, we're going to keep going. So, underneath, we don't really have a title on this page, but I would like you to draw a 6x3. Let's make this a fast array. A 6x3 fast array on the next blank page. What's a fast array? Someone remind me. We did that on our distance learning. You should watch that video. Grace?
It's kind of when you make a 6 on this side, and then you make a 3 right here, so you know that there's more over here, but it's just fast.
We're going to do one row and one column, and that's it. Because you can imagine the rest in your brain. Go ahead and make that 6x3 fast array. I know we drew a fast array, but 6 times 3 is not 9. Remember, you have to fill in those gaps. Really? 18. Let's draw our big arms. Let's say all of that, even the invisible ones. Equals 18. Cool. If I know a 6x3 array is 18, how can I use that information to figure out what a 7x3 is going to be? I don't want to draw a 7x3. Oh, I already have 6 groups of 3. I want to use that. How do I use 6 groups of 3 to find 7 groups of 3? What do I need to do? Ethan, what do I need to do?
You have to have one more to the one on the side.
Yeah, let's write that. To get a 7x3, because that's what we're doing. We're trying to get to a 7x3. I need one more group of 3. Now I'm going to change that English into math language. So the math language version of that is going to look like this. 6 groups of 3. I have that to start with. I'm going to put it in parentheses because it's a little group. And I just said I need one more group. Well, if I'm adding one more group, then I'm going to add in my math language plus one group of 3. I know what that is in math equation language. One group of 3. And I'm going to put this in parentheses because it's its own little group. And I know when I add these two things together, it's going to equal 7 groups of 3. That's a really long, fancy-looking equation. But you know what that means. You just wrote it in English above. 6 groups of 3 plus another 1 group of 3 gives me 7 groups of 3. This is the English version right here. And this is the math language version. They say the same thing. They just look a little different. Very different. Alright, well let's solve that. What was 6 groups of 3 again? Is that right? 18. Plus 1 group of 3. Lucy? 3. Equals. Tricky math we're doing there. Right? 21. So 7 groups of 3 is equal to 21. Pretty neat, huh? Alright, next page, unless you have room. Create a 6 by 8 fast array. 6 by 8 fast array. Remember, I don't want the whole thing, I just want a fast array. Alright, we have a 6 by 8 fast array. Should look something like that. If you did 8 going up and down and 6 across, would that still be a 6 by 8 fast array? Scarlett?
Yes.
Yes? Because?
This property says that you can switch your numbers around and then you'll still get the same.
Yeah, so an array is not so finicky. I always do rows and then columns, but there's not a real rule. Now, if I was drawing circles and dots, it would look a lot different because 6 is the number of groups versus 8 groups. That would be different. But an array, we can just kind of turn it, depending on where our rows and columns are. All right, so underneath this, let's go ahead and write 6 times 8, because that's the picture we just drew, equals box. We know what 6 times 8 is. Let's do what strategy? Right on, what strategy you want to do? I think that is a really good strategy.
Because it's 2 big numbers that we have for skip.
We have 2 big numbers. We don't have good skip counting numbers. Also, my 6s, when I break them apart, can I get 2 easy numbers from that? Yes. So let's go ahead and break apart my 6. What easy numbers would we like to use? Preferably numbers that also make up 6. Bryce, what you want to do? I love 5s and 1s because I can do them so easy. Alright, so let's do our first mini equation. The first part. Ready to get in your seat? Let's go. 5 groups of 8. Put it in our little parentheses because it's saying this is one mini part. That's only one part. Now I have to do the other part, which is going to be 1 group of 8. Now that I have my 2 parts, what math operation do I need to use to get them to be a whole again? Am I going to subtract them? Am I going to multiply them? What am I going to do to put my parts back to whole? Miranda? Add. I'm going to add. Alright, let's fill in what we know. Brayden, you got one more time with that pencil, and then we're switching to wood. 5 times 8. That's easy. I can skip count. 5 times 8. Watch, see you skip counting on those fingers. Right? 40 plus 1 times 8. I should see you just raising your hand because you don't even have to skip count. You should just know. Miranda? No. 1 group of 8. Scarlett? 8. 40 plus 8. That's an easy equation. Miranda, get it up. Ethan?
48.
48. Sweet. 6 times 8 is 48. Awesome. Right. How can I make that into a 7 by 8? I want to know 7 by 8. What would I do? I just figured out 6 by 8. I just made a 6 by 8 fast array. How would I turn that into 7 by 8? Ethan?
Put one more on the line down.
Yes, I want better language though.
Put one more circle on the one where it has 7 dots. Circle.
I don't have 7 dots. I have 6.
7 circles.
And I have 8.
Yeah, 6 circles.
What does that one circle represent? Because there's a lot of invisible circles next to it. Grace, you know? We're really adding one more group of 8. Is really all we're doing. Let's practice some counting on. Because I can count up to 8. That's easy.
1, 2, 3, 4, 5, 6, 7.
So I'm going to count on starting at 48. One more group of 8 with my fingers. Ready? Make a fist. 48. 49. 50. Count with me. 50. 52.
53, 54, 55, 56.
So 7 times 8 then is
56.
awesome. We'll just write that fun fact out to the side. 7 times 8 is 56. We figured that out because we knew 6 times 8. We just need to add one more group of 8, and we're able to count that on. All right. We're going to look at our 7's multiplication chart. Flip back to that multiplication chart. We're going to fill in our 7's. There's very little 7's you don't know.
Got it. Ebook multiple.
Yep, you should have.
So I just easily got it.
All right, what is a 7 fact that we don't know yet? This is where this hole's on. Friendly?
7 times 6.
7 times 6. No, we did 7 times 6. We did that with our 6's. It's 42. Make sure 7 times 6 is 42 in it. Lucy?
7 times 7.
7 times 7. And what is our other fact we don't know? Brayden?
8.
7 times 8. So what we're going to do, we're going to flip back to where we were in our notebook. And I want you to use whichever strategy you want. I recommend break apart, but you can do you. And I want you to solve 7 times 7 and then 7 times 8. You can do it on the next blank page. Solve 7 times 7 and then 7 times 8. Once you figure them out, you can add them to your multiplication chart. I recommend you use the break apart strategy, but you can do whatever you want. We figured out what's 49, and then 7 times 8 is 56. Is there anything else I can add in my chart? Lizzie? Yes. Why? Yes. I will continue to feed you Hershey Kisses every time someone tells me I can go across. We just did 7 times 8. I can now do 8 times 7. It's going to be the same product. So now I have one. That's not my problem. Now I have one fact left. I have one fact left. What is that one fact or one multiplication fact that I don't know yet? The one multiplication fact we have left. Scarlett? That is not a multiplication fact. That is just a number. Eliana?
8 times 8.
We don't know 8 times 8. Every other part of your multiplication facts should be filled in. Great. We We just need 8 times 8. Let's do break apart. Flip back to your next spot. How are we going to break this apart? We have a couple of options. What's one way I could break apart 8 times 8? Miranda? That is not a way to break apart 8 times 8. What is one way to break apart 8 times 8? Bryce? That is not a way to break apart anything, guys. I'm looking for numbers. No, that's not okay. Bryce?
We can do 4 and 4.
I can do 4 and 4. Right? I could do what? What else could I do? I can break it into 4 and 4. I can break it into, Brindley?
5 and 3.
5 and 3. That'll work. Any other ways? Ethan?
0 and 8.
I could do 0 and 8. I could do 1 and 7. I could be 2 and 6. These are all ways I could break apart this number. I'm going to let you choose. This is likely easier. These two are likely the 2 easiest ones. So I would pick one of those 2. But however you want to do it. Break it apart. Solve 8 times 8. Most of you did 5 and 3. Could have done 4 and 4 to break it apart. And now we know that 8 times 8 is 64. Now, even though most of you have a filled-in multiplication chart or mostly filled-in multiplication chart, notice that when we listed our strategies, did we say, look in our multiplication chart? No. I know that you have every single math fact in here. I know that. But I need you to use your brain when we're solving problems. Could you look in your multiplication chart? You could. But that multiplication chart is not going to be available to you when we have our test. It's not going to be available at the end of the year on the EOG. So you need to have an actual strategy, not just look up the answer. Does that make sense? Great.